everybody. We're going to go ahead and get started here. Hope you guys all had a great start to your tech ed and a nice lunch. I'm really excited for this topic that we have prepared today, how we do language design at Microsoft. I do a lot of work in the community, and I often get questions about this. People are often very interested to understand the process behind how we design and develop these languages that millions of people are using every day. So I hope this panel will be a good opportunity for you to get some insight into that and also ask some of your own questions as well. So to kick this off, I'm going to start with a round of introductions. We have a number of experts on the panel here who are deeply involved in this process. And so we'll kind of walk through the line here and give everyone an opportunity to talk about your current roles and also any additional context from your experience in the past that might give folks some insight into your current perspectives. So why don't we start with Don and go down the line, and then I'll finish up.
Yeah, sure. Hi, everyone. My name is Don Syme. I'm a principal researcher at... It's a bit loud at the back. Got that? Principal researcher at What have we got there? Am I too close to this? I'll try walking over here. Maybe it'll work a bit better. Yeah, principal researcher at Microsoft Research in Cambridge. I'm the designer of the F# language. Also had the privilege to work on C# 2.0 and VB, I guess, tangentially through .NET Generics, and also tangentially C# async, I guess. Been working with these guys and seeing VB async. Sorry, I made the big mistake, Lucian, of not saying VB and C# async, because I think the async feature in VB and C# has been definitely an equal partnership between the C# and VB teams, and also at the F# team in the predecessor to it. So. Yeah, that's who I am. That's what I've been working on, and over to you guys.
Hi, my name's Lucian Wishick. I'm the VB spec lead and also part of the C# and VB language design meetings that happen every week. I joined Microsoft 7 years ago. Before that, I was in academia, and basically I've spent my entire academic life and my entire Microsoft professional life working around the area of concurrency and that kind of stuff. And actually, since we came out with async last year, it's the big feature that will come in the next versions of C#. VB was already out there in F#. I could go last year on a speaking tour of my old university haunts, my old PhD supervisor, my old postdoc supervisor in Italy. And the very first slide was, this is what the academic research was about. And a big cross through it saying it was all the wrong direction. What we've come up with here now was a more exciting and more practically useful direction. That was very exciting. I also love swimming and outdoor exercise. I was just rafting in the mountains of North Georgia this Saturday. Beautiful weather. I love it. It rains less here than Seattle.
Cool. Yeah, my name is Alex Turner. I'm the program manager for the VB and C# compilers at Microsoft. My history, I've been here for about 4 years now at Microsoft, and then prior to that, for the 2 summers before that, I was actually an intern at Microsoft from college. And I remember the first time I was there, we were first doing what eventually became Link. This was sort of the summer of 2005 before PDC. And sort of my one claim to fame then that summer was I wrote if I don't know if you're familiar, the 101 Link samples that were out originally as part of the Link CTP. And I remember the big thing of spending weeks on it and getting all the different parts, trying to make them all unique, and kept having these design meetings with Anders and coming up with like, how far are you, like what are the topics, and getting it closer and closer. And finally it was like the final week we needed to lock down all the bits we were going to put on the disks for PDC, and we get to the end and it's like, all right, well, how many do you have? How many samples do you have? It's like I have 101 link samples and 101 link to objects and 101 link to SQL samples. And he had previously promised me $1 for every sample that I got done that summer. And so out of his wallet, he pulls out $200 bills and 2 $1 bills and hands them across the table. And I'm like the whole summer is sort of coming to a crescendo. I'm like, this must be like a test. Like everybody who's important is like sitting in this room staring, and I don't know what to do. So eventually I just reached and grabbed the money. And I came back the next year and people were like, oh, it's you. You were the guy in that meeting who took money from Anders Hallsberg. And so it was a pretty good way to set your career at Microsoft going.
Awesome. Yeah, Alex did such a great job on the 101 link samples that in the async CTP he and Lucian worked together on another set of 101 samples. So It's a good trend. So my name is Lisa Feigenbaum. I'm the community program manager for this team. And in our product unit, we have the managed languages, C#, VB, and F#, which we're going to talk about today. Also the IDE and extensibility. So that's some of the scope of what we cover. As community PM, my role is, one, the content that we present out. So at conferences, on our MSDN developer centers, forums, blogs, etc. And then the other half is bringing in feedback. So we'll talk a little bit later about, the process of how much users and customers really influence the language. And we're extremely interested in hearing feedback both about the development scenarios that you're working in, your feedback on our specific language features across the board. So I've been on the team for 7 years now. The first 4 I spent as IDE feature PM, so designing the IDE features. That was for the 05 release and the 08 release, deeply working with Link and how we show IntelliSense for Link and all those set of features there, colorization, etc. Great. So the format that we set out to do today is we have a set of questions here that kind of give you a large picture of all that goes into language design and include some of the really common questions that we hear from the community. So we'll start to go through these, and I think as we do, you'll hear some interesting anecdotes and get a sense for the process. We also want to hear your questions, so if you do have questions, please do come on up to the microphones. We'll try to kind of stay on these topics initially, and then we'll also reserve time at the end. If there are other questions that you want to ask, then feel free to come up and ask those as well. All right, so first we wanted to talk about, we have several languages here that we're talking about today, and as we talk about the language design, it's important to know who is the target user base, who's using these languages today, and how are we trying to design for those users, and what are the language's goals. So we'll start off with a quick panel review on that.
Sure.
So Don, if you want to talk about F#.
Okay, so most of you will be a bit familiar with the F# programming language. I think the key role for F# that we envisage is for writing core computational components, very much server-side analytics kind of components, perhaps also executing some of those components on client side, but definitely not. We don't think of it as a client-side UI programming language, web programming language for the front end of the web or for the WinForms or WPF. You can do those things with F#, but in general, we would say that the focus of the language is on core analytical computational components. That is partly driven by some historical rationale in the reasons why we decided to embrace a functional programming language on the .NET platform. That's got partly to do with some financial companies who adopted F# quite heavily and actually asked for it to be productized. And we added that up with all the other reasons why it's good to do a very, very code-focused, problem-solving, analytical language for cracking out the solutions to difficult analytical problems in code-oriented form. And that's there's lots and lots of good reasons to augment the platform with a language which is just great for people who are solving hard coding, analytical coding problems. That said, we didn't just focus it on what you might think of as traditional high performance or scientific kind of programming. We think of it as a modern analytical programming language in that analytical programming today is often asynchronous. You're about processing asynchronous streams of data or doing building a component which has to, if you think about what makes up a modern service such as the Bing service, then as you take in requests, there's a lot of complex analytics that has to go on under very tight time constraints to do with talking to back-end services. And so you can see that as a sort of advanced I/O parallel distributed kind of programming problem as well. And there's a lot of overlap between the traditional analytical programming problem solving and problem solving in the sort of multi-core distributed I/O intensive server-side kind of programming work as well. And so we definitely see F# as being a language to help you solve complex problems with simple code. I guess one thing, we can talk more later about what we're looking at towards F# 3.0, which is extending that out to all sorts of data-rich problems. We've looked at control-rich problems and analysis-rich problems, algorithmic problems. In F# 3.0, we're doing this amazing set of features to explode the amount of strongly typed data that you can work with in the language.
Great.
You know, this question makes me think back to 15 years ago. You're a developer, you sit down with Visual Basic 1, codename Thunderbolt, you type away and it's all a complete solution for you. It creates the Windows Program Manager UI, it connects to the database. It's all very straightforward. And it was great then, and the landscape now has changed so much, and there's so much you have to know, all of the different technologies and N-tier, and you've no longer got the single language complete solution that will take you all the way to the answer, unless you switch to something like LightSwitch. And it means where we've filled the gap is with general purpose programming languages, and it really does have to be general purpose. And I think we're torn in one direction, right at the top, probably where a lot of you guys are. We're thinking enterprise. You're probably the sort of people who treat warnings as errors, and you want to have very clean code, and you understand the principles. You understand the lambdas even, and you like them, and that's at the top. And we have to be very conscious that there are far more people writing regular line of business applications, and then at the bottom of the pyramid, there are zillions, far, far more of them writing Excel programs, the world's most popular programming language, or Visual Basic macros in Word, or JavaScript actually. And so the users that we're looking for are higher than that. They're the kind of top half of the pyramid. And I think all of the time we're fighting in ourselves the instinct from our backgrounds and our language design things to keep aiming even higher, and we're always trying to keep ourselves grounded in what's practical for a larger number of users.
Yeah, I remember back, my own personal history, I ended up using Visual Basic for a while before I was even in college, and using this kind of stuff on my own. I worked at a company that did a lot of Visual Basic development. And I remember, like, by default, you would turn off a lot of the things. They would just come with option explicit off, and they didn't even have things like option strict then, so you got all the implicit conversions. And I remember I always used Visual Basic in a very constrained way because I wanted to think about architecture, and so you'd turn on option explicit, you sort of force yourself to make things into separate classes, which was more annoying to do in that day, and really sort of set up the programming environment the way you wanted it. I remember when .NET 1.0 came out, that like the big push then was, hey, we have this new object-oriented platform. Visual Basic introduces things about being more strict. C# is a language that's very strict all on its own, right? It's all about exactly specifying what it is you want to do and holding yourself to that to catch errors and to enforce your layering within your app. And it sort of was filling that sort of middle tier. You sort of had C++ on the far higher end, and you had like VBA, which ended up being VB6 as a programming environment on the other end. And we sort of think about that middle ground that Lucien was talking about, of actually maximizing that productivity benefit of saying, hey, you're in the middle, you're coding in managed code, you have a lot of the benefits like managed memory and all these kind of things, but we try to do sort of just enough to get you there without doing too much that it becomes a lot of checkboxes and formality to actually get your work done.
And you know, the thing is, one thing to work in there, and this is
Sure.
work out well when you talk about being grounded and everything, please also work in the business side, like especially obsolescence. Some of these things you mentioned, you know, okay, if we do one of these top tier languages, are we going to get abandoned and stranded later on? What do you do to give us a path forward so that we can work our way out? Is it option explicit, or do you work with third parties so there's tools to work our way out?
Right, I mean, like, definitely with VB6.
We should probably repeat
sure.
that for the microphone.
Sure.
I don't know, does everyone hear that? We do have microphones in the middle when you come to give questions later. Just to repeat, keeping the feet on the ground, how do we manage business applications, how do we stop things going obsolete?
Yeah, and definitely, I mean, the company that I worked for, sort of that VB6 to VB.NET transition was a big deal for us, and I think when I left, they still hadn't moved, and I think they're still trying to figure out what that means for them today, right? And so definitely that was a learning experience for us at the time. It means a lot for us now as we think about moving stuff forward. Breaking backwards compatibility is a huge thing that we have to think about in the platform, and it's a lot. It's better to have gotten us to where we are now with .NET, to where we feel we have a stable enough platform that we can iterate it in a way that we don't have to break backwards compatibility and let things install side by side and give you that better story. I think it'll be a while before we would do the kind of leap that you would end up feeling left behind the way people did in the VB6, VB.NET era. It's definitely something that's foremost in our mind at every release.
Yeah, the VB6 to VB.NET is often talked about inside Microsoft as just being a major issue in the languages space. I think even today it's on people's mind about taking the VB6. Should we be taking the VB6 community?
Right.
It's still through the VB. It is an aim we have, but definitely there's a widespread understanding that transition was a difficult transition for some businesses, and that people. I think maybe in the comment section it'd be very interesting to hear from people about how well that was managed and whether in the end the way it was managed was worth it or what could have been done better as well.
Okay, so next we wanted to start to talk about kind of where we're headed with these languages. What are some of the new features that have come out in the latest release in 2010 that many of you are using today? And then what are the areas that we're focused on for the next version? So I wanted to talk about a few trends here. I find sometimes this is a useful context to give people some framing for where these features came from. These are some development trends that we see. And the first one, calling it declarative, is kind of a design principle that you'll see across our languages, which is where we're trying to increase the abstraction layer, where rather than having you describe in detailed steps what the compiler should do, you can explicitly just say more succinctly what you want the program to do, and the compiler will take care of some of those additional details. So LINQ was a great example of this, where instead of having to write all of those for loops, you could say, from this data source where this condition is true, select these values. And that was just a much more fluid way to describe that program flow. Dynamic is another one that we focused on in the last release in 2010, where we wanted to find better ways to work with dynamic objects and dynamic languages. So that's where you saw the dynamic language runtime in .NET 4, and also the dynamic features in C# and VB.NET. And then concurrency, this is something that's a huge trend, looking at the trends in hardware and also cloud, clusters, has become more and more important. This is an area where F# has definitely led the way across the languages. And Don will talk more about some of the features that we have in F# today to address this scenario. And then that's also something that's led into C# and VB and the next release that we're looking at, and the language features there. This is also another scenario where there's platform support. So in .NET 4, we have the task parallel library, plink. So this is a language and platform creation. So I'll go back and then kind of go through the panel and let folks talk about some of the features in 2010 and then also in the next release that you're working on.
Do you guys will I kick off?
Sure. Yeah. So with 2010, like Lisa was talking about the dynamic stuff that we did. A lot of that, we looked around. I think when we first talked about dynamic, there was a lot of worry. Like, wait a minute. So we like C# because it's a static language. What exactly is going on? Are you trying to make C# a dynamic language? For us, it was really about sort of looking around and trying to be a good citizen of the .NET platform overall. Back, you look at like .NET 1.0, a lot of the promise of .NET is the fact that you can target the runtime from many different languages. We've sort of had VB and C# as our primary languages that we push, but you get people who are moving sort of Fujitsu COBOL kind of stuff, moving their COBOL code forward. You got people doing Iron Python, Iron Ruby who are starting to do dynamic code. And you don't want these things on a platform that's supposed to be about interoperability to be little islands where, well, technically it's .NET, but I'm going to go over here and run my Iron Python program, and it's only going to interact through invoking a process that's over here in VB. You really want it to be a lot tighter. And so we did the work to actually add that, mostly for interop purposes when you think about it. So it's not so much about really sort of the core dynamic programming stuff within C# and VB itself, so much as we know there's going to be a dynamic library you want to talk to in Python. We know you want to interact with the DOM in Silverlight, the underlying DOM in the HTML page. And this is going to be something where there is dynamism already. It's already a dynamic API. It expects to be interacted with in that way. And so bringing the language closer so that it's actually able to talk to it directly, speak sort of the API's language. And so we sort of embrace these trends cautiously, again, because we don't want to sacrifice what it is people really do like about the languages, but we do want to sort of get on board.
I have nothing to add.
So I was actually going to cut the trends a bit differently than the way that Lisa did. I think saying that these language things, dynamic and concurrent and declarative, are trends in and of themselves, can forget that those trends are actually rooted in the real world, in real trends in the industry, in the work that you guys have to do, that people have to do day in, day out. And the underlying trends there are, well, there's multi-core on the concurrent side is one trend. Data is, this unbelievable sort of rise in the amount of data, the degree of schematization of the data, the availability of data in networked form, but just the sheer total amount of it. You see, I'm sure you've read the articles on things like the data deluge, or looking at just the graphs of the amount of data being stored. The trend of the web. Yes, we all experience that every day, but that's how that is just continually just transforming programming. I've kind of got this belief that sooner or later we all get wiped out by the web in one way or another. It's like the web is like a tidal wave that keeps coming over the industry in many different forms, and we've got to be on top of this with the languages, not necessarily tying ourselves just to the latest fad. The latest, XML was a very big fad or something, and that just tying yourself to that is the only way to do things, or we have to be building the languages in a way that they're going to survive for the next 10 or 20 years, and for not just survive, but actually really thrive in the environment that's coming up. And so when you look at the trend towards declarative programming, that's got a lot to do with the way that data's always been driving our application development, but it's doing it in, and so the integration between, with the SQL Server databases has always been absolutely critical to languages. But now we're seeing that the integration with web-based data sources, web services, or OData feeds is becoming critical. The integration with not just SQL data sources, but NoSQL data sources, and also SQL data sources which have scalability properties, which are very different to the traditional SQL Server view of SQL view of scalability. So that's on the declarative side. On the concurrency side, well, we're not just talking about concurrency with multi-core. That is a big trend, but I actually think people have overemphasized that trend because we've been ignoring the web a bit too much. We've been ignoring the rise of communication and the absolutely critical role of communication in program construction. And I think that's the trend that underlies the work on asynchronous programming that these guys, that's such a big deal for VB and C# in this release, and for F# in the previous release, and Visual Studio 2010. And then the other trend you had was dynamic. Okay. And coming from a language which de-emphasizes dynamic programming techniques, you can do them in F#. It's a .NET language. We actually have a language feature hidden away which has sort of the same sort of logical power as C# dynamic. What's the underlying industry trend there? I actually think that is very much about connected, information-rich programming. When you look at why do people actually like these dynamic languages, right? Why do people like PowerShell, for example? Great language, very effective language at what it does. But it's one characteristic it has, I believe, is it's an information-rich language. You have the You sit down as a system administrator, you have all the information about your system's network sort of very in your hands. It's very much available. You just have it there. And dynamic languages excel at those kind of information-rich programming problems because they tend to create very little impedance between you and the data. And we are taking a different cut on that in F# in the forthcoming versions of F# with this type provider feature, which I'll be talking about on Wednesday in my session. But those are the big trends. I just wanted to say the trends aren't just about language design. The trends are about real-world programming trends and real changes in the kinds of programs that we're building and what we can do about them right down at the language level to help solve those problems.
Absolutely. All right, thanks, Don. So I think now that we have a sense of, who are the users that we're targeting, what are our goals for the languages, what are some of the features that we're implementing, let's now start to talk about the process, how we actually go about designing those language features, implementing them. So I'll ask Lucian to talk about the language design meetings that we hold and kind of the process of design in those meetings. Maybe Alex talking about kind of the day-to-day triaging bugs and kind of driving the team. Don, there's a whole set of things you could talk about here, the community process, CTPs. I'll kind of leave that open to you.
Well, language design. Once a week we have a VB language design meeting. Once a week we have a C# language design meeting. But the people blur on both sides because we design all new features in both languages. We have such a big cutting room floor pile of good ideas that didn't quite make it. We get so many suggestions from users. We have so many ideas ourselves from other languages, requests from the .NET framework, and we go a long way with the ideas. We write how the language would work. Sometimes we make prototypes. And then it always comes to the next release cycle. You've got the budget for 5 new features plus 3 small features, and there are so many nice ones that get dropped. There are also some really nice ones, like I notify property change and dependency properties in WPF. Always a pain to write, so much boilerplate code. We would love to have a way around this. Some people think, do macros like C or C++. We really don't want to do macros. We've explored so many other possibilities, some things like Java annotations. None of them have quite felt clean enough. And it's been a really important, Don was saying, design a language for the next 20 years. If we put something yucky or incomplete or with rough edges now, it's going to curtail the lifetime of the language. So we only put in the features that we're sure have hit the exact right thing. Let me give you one example of that. Link. We didn't start from nothing from there. We started with, been done a lot in research and academia in other languages, and we could see that we had 3 practical use cases of that. Link for objects, XML, SQL. We knew pretty clearly how it would fit together, and the more use cases we see of it, the higher confidence we have. If we see only a single use case of a feature, that probably means we cut it. And no matter how beautiful it is, we don't do it. There's a saying from Groucho Marx, I think. He said, I wouldn't want to be a member of the kind of club that would let me be a member. Eric Lippert says the same thing about languages. I would never want to use a language that used the features I wanted in the language.
And you talk about that long list of features that we get requests for, and if all of those features were in the language, you probably wouldn't want to touch it with the 10-foot stick.
Right. Yeah, and remember one of the things we always look through, so we maintain like a list. People submit things on Connect. You guys have suggestions that you put in. We sort of group them together, which ones are actually asking for the same thing, which ones are asking for certain underlying things that we already are tracking, and we keep this sort of prioritized list. And always near the very top of the list is this request for basically type-safe access to reflection. So some sort of, we have type of, right? You can say type of, and then the type token, it'll give you back the reflection type object. You could have, imagine a member of, or local of, or something like that, where you give it the actual variable reference, and it would give you the type-safe access. And that would be sort of a general purpose way we could imagine solving the notified property change, because you could have a simpler thing you could just pass and have it capture that state. And so we've constantly been thinking about this. Sort of every release that comes back up, we go back and we start thinking about what we can actually do in this space. And it comes down to that question, are we actually adding a general enough language feature? And we look and we can never quite come up with the syntax that would let you actually disambiguate all the things you'd really want from such a feature after you get past the surface. Actually figuring out which overload of a method you're talking about when maybe the only difference is related to certain generic type parameters and the specific instantiation you're in, and the actual syntax you'd need starts to explode. And so we often have to decide, do we want to do this sort of halfway feature or sort of quarter-way feature to do a certain core set of value, or do we really want to hold off until we have a solution that works for the whole thing? In some cases, we've actually done that halfway value. We've decided, you look at auto-implemented properties, right? So we decided it was more important to have auto-implemented properties out there, even though we didn't get to saying like initialization, or if you want to make it read-only or something. It was more important to actually get the value there. And then you can consider going back and doing those extra things later. And so we have to, for each feature, figure out that balance. Is it worth sort of half the value, or do you really need the entire bucket before it's coherent?
Yeah, I think another example with that one was the line continuation removal in Visual Basic. For a couple releases, we had thought about removing the requirement to have to type and read those underscores at the end of continued lines. But there were these very specific kind of ambiguous cases, and we said, well, it would be too confusing to remove them because people would have to deal with, if you have a link statement that ends in select and then you have a select case, is it corresponding to the line before or line after? And then we went back and we found that 95% of the time where these are cumbersome, when you have argument lists or parameter lists, binary operators, attributes, that's a large enough value to kind of deal with some of these ambiguous
Yeah, so sometimes it really is just about trying it out. Like that's where actually making the prototypes that comes in handy. That's one of the things sort of moving forward. We're going to touch on it too much here, but we've talked about compilers as a service kind of stuff. And if we can actually even reduce the cost for us to prototype new language features that are really sort of be something that we can use internally to figure out, hey, if we actually add this feature, if we add that feature, what would this mean? And really give us the data we need to help us see where it makes sense to do those kind of scoped feature sets.
One of the funny things about this is that you quite often get the situation that you'll have a discussion with someone who has to make these language design decisions, and you propose a particular change, and they'll give you a long answer why you can't do that because of some corner case. It's it's just too. We thought about doing it and we decided not to do it, and then they next release or something they just change their mind, and they do line continuation removal, and they decide actually we could do it. Yeah, it was okay. I mean there's been quite a number of people I think interacting with the C# design process. The var keyword. That people have been suggesting that I think for since C# 1.0. Do I really need to write that type twice? Especially with generics. I said, do I really? There was always good reasons not to put it in, and then. I think dynamic was another case where we were looking at COM programming and deciding at what point we want to add dynamic to C#, for example, and it depended on a lot of things. COM was such a large scenario there, and based on how Office programming models might change, that would change the importance for this feature. And at some point, we just said, well, this has been a paradigm for a long enough time. And sometimes the strange thing is that the answer it actually is not yet. We can do a feature, but we shouldn't do them all at once. It is actually a good thing for C# that C# didn't come out with the full feature set of C# 5.0 or whatever it would, 4.0 or 3.0 or any of those. If that had all come out at once in C# 1.0, it would have been too much. It would have been wrong. It would have been, and you could. I don't think C# has too many features in it today. It's got a fair number. It's got a lot of features. But I think the fact that they've been introduced to the community and a real wisdom has developed about how to use those features well, and methodologically, design, and everything else that goes with the set of features is a crucial part of the process. So things do take time. Things have to be timed right and put in together in a sensible overall package in each iteration of the language design.
And we also get these conflicting requests where sometimes we'll have all these requests, oh, please add this feature, and then we also get it's too much too fast, I can't keep up to speed with all that's even in there today. So just trying to manage that optimal pace. So I'll repeat the question. The question was about as you go through the day-to-day and you're deciding for each feature whether to include it or not, do you look at the value prop for each of the languages that it applies to individually, or looking at that together? So we do have kind of separate language design meetings across C# and VB and then F#, because we did talk about how we have different target goals for each of those, although obviously there are some overlaps. So when you look at, like for C# and VB, for example, we do at this point make those decisions together. So there was a point where we didn't always have common goals for those two languages. We did at periods differentiate, and then the overwhelming feedback that we got from users was whenever there was a feature that it was in C# and not in VB, or in VB and not C#, we really didn't add much value because all we did was upset the other half of our customer base. So we finally came around on that, and I think especially looking at the 2010 release, you'll really see a more united front there, where you see a bunch of features that were previously VB only are now added in C#, features that were C# only are now in VB, and then the new language features that we did were really done together. So for C# and VB, I would say we definitely make those decisions together, and then I'd say that as far as C#, VB, and the F# process, that those can be a little bit more independent.
Yeah, I would just follow that, because the question then is, so many of the features that came early into F# or were exposed early nicely in F# ended up getting assimilated in VB.
Yeah.
And it's that kind of, if the end goal of everything is we take your distinctiveness and add it to our own.
Yeah, I mean, it's an interesting question.
Let me just repeat this
Yeah,
one,
sorry.
because we do have folks on the live meeting, and we always get eval comments about not being able to hear questions. So the question here was, if many of the F# language features are moving into C# and VB, don't they really have the same goals, and is that really the end goal here?
I mean, it cuts both ways, because we're very aware that one of the reasons why we decided to do F# was to keep the platform invigorated with ideas and really drive those through into product form and to get a pipeline going of ideas. So at a personal level, that is a success for me. Every time I see C# VB adopting an idea or being influenced in an idea, I do consider that a success for the research agenda and a big success for Microsoft Research and the group that I'm involved in. And I think your question is about, like, does that erode the value add of F# in particular? So there's, I mean, maybe in some way, and I don't want to be. There's some the features we're talking about in, say, let's take F# Interactive, the asynchronous programming, the type provider feature, the immutability in F#, the functional programming in F#. These are features which actually work better when you're working in that zone, together in the functional programming zone, okay? And that means you actually, that it is a less is more thing, okay? That F# is a more powerful language because it doesn't have the really strong emphasis on mutation programming that's in C# and VB. And you see that in the asynchronous programming. As much as these guys have a wonderful asynchronous programming feature, I am confident that asynchronous programming in F# leads to far more correct asynchronous programming code. And I know that. I can tell that because it's the way it plays with the lack of mutation and the way it plays with the way, if you look at the way we do object-oriented programming in F# and the way you capture variables during construction in object-oriented programming in F#, it makes it much less error-prone than the equivalent programming in C# and VB. So the value of F# is it's not just about adding up the features. It really is about getting correct solutions to complex problems in the functional programming kind of space. And that, of course, you can do that in C# and VB as well, but there's a zone there for functional programming which is deeply major value add to the platform. And I think everybody at Microsoft understands that value add, that value proposition as well.
So then that drives
In the-
requests for immutable types in C# and VB also.
No, that can drive those requests, but it's the fact you don't have certain things. F# does give an entry to the .NET platform, which allows you to ignore a whole set of issues which you have to be exposed to in the C# and VB worlds.
Yeah.
And that's a core value add. Less is more is a key phenomenon in the languages.
And I mean, that's where it comes down to sort of the character of the languages too. Like, if you look back, we could imagine all sorts of things that we could have imagined differently for .NET, right? So nullable was something that sort of came about later on. If you look back to the original release, you could imagine a .NET where by default things are non-nullable, and even for reference types, you'd sort of opt in. And some of these kind of decisions you could make early on, we've already sort of cast in a certain direction to say, this is a language where you can use null for these purposes. This is a language where mutation, like Don's saying, is something that is core to the way you lay out your flows. And there's room when you get languages that can focus in different domains that you can have the character of that language be more optimized for certain scenarios. Sort of the curse of being a general purpose language is that you embrace certain general ideas that are very generally useful, like mutation, and ultimately then you're constraining yourself in certain very domain-specific ways, like to say that I'm going to be as maximally productive as I could be for something. So it is that kind of trade-off, like portability of skills versus really efficiency in getting something done in a certain place.
Yeah, I think that comes down to, it's actually a challenge I often give to the F# team, which is our job is not to go and poach C# programmers, right, and convert them over to F#. It is one option is to give C# programmers a different analytical problem-solving tool, and we're very happy when C# people use it and like it and so on. But if we have languages in our language user groups in our sites, we would like, I do like to see Python programmers. I think there's a lot of commonality between Python and F#, right, in ethos and in the domains of use of those languages. And I do like to see them discovering that you can get a lot of the benefits of Python in a strongly typed programming context. And you can take some of the other popular dynamic languages. There's some elements of Ruby have good overlap there. And it's also, I love it when I see Java programmers discovering, or Groovy programmers discovering similar kind of benefits from the F# kind of approach. And yeah, so we have to remember even if the response to the C# programmer or a VB programmer might be, oh, I've got async in C# VB, I don't have to worry about F# async. But we've got to remember, how does the language look coming from these other, like the JavaScript community? F# actually has a lot of similarity with JavaScript when you, in some ways as well. JavaScript is a very functional language, used in a very functional way for many people. And so I want us to be focusing on how does F# look to those communities, not just to C# and VB.
Great. So I'll bring us through the next couple of questions here because I think we've touched on these, and I want to make sure we have time for the other questions here and also for yours. There was one here about how does language design come from research, and we talked about LINQ, how there was a lot of research influence there. Obviously with F#, which started from the research group, before moving into the product group, that's a huge success story of language design coming from research. So it's a lot is the answer there. How much does language design come from users? We also touched on this, looking at those long feature request lists. And those lists get created from feedback that we get at events, from emails that we get, from comments on our blogs, from Connect. That was a source that Alex talked about, connect.microsoft.com. Every suggestion that you enter in there actually comes into our TFS database, and we triage that with the rest of the team. So that's a great source for us to bring in suggestions from the group. We also have a lot of different feedback programs. So we have something called the Technology Adoption Program. So if your enterprise is looking to move to the next version of Visual Studio, that's something you can work with our developer evangelism group to become a part of, and we can actually work with you during that transition. And that's a great way where we can really get early feedback as people are starting to use the next release. Other ways that we enable that more broadly is through CTPs. So F# has been driving CTPs for a long time. This has been a great process to bring in community feedback. Also with the async CTP, that's one way that We started talking today in the keynote about Visual Studio vNext. We already have bits out for the C# and VB languages that are going to become part of vNext. And so that's been a great way we can start to collect early feedback. We have hundreds of threads on the forums there, so we're getting good traction and early feedback there as well.
Hey Lisa, can I tell a story about the TAP
Please
the
do.
Technology Adoption Program? So we're about to release Visual Studio 2010 in 6 months' time or a year's time, and we're looking through, and we notice Visual Basic, if you have a function which returns, say, an integer, but not all code paths return the number, it doesn't warn, it doesn't give an error message. C#, of course, does give an error message. So we thought, if the user forgot a return statement, or if their control path was a bit confusing, it was probably a mistake on their part. Let's add a warning for this. Makes obvious sense. Okay, we share the early builds with the TAP partners. We get back a very irate email. He says, "You stupid," he didn't use the word stupid, but it sounded like that. "I upgraded to the next version of your product and it broke my solution." And he sent us an Excel spreadsheet with 10,000 build errors he got. It was a large solution. It was like 90 projects and zillions of files per project. We looked through these and we discovered that 4/5 of all of the warnings, he treated warnings as errors. 4/5 of the errors he was getting were places where he hadn't returned a value on all code paths. And we did statistical sampling. We found that about 3% of these cases were actually bugs in his own code. Nevertheless, the underlying message that we've really learned, and each time new people come to the team we have to learn it again, is you can't just break code. If it's working and if it's compiling clean, and then they pay us, or you pay us, substantial amounts of money to upgrade the next version, and suddenly you have to start doing work to make it work again, that's just impossible. We can't support that.
Yeah.
What we did with this story is we did add the new warning, but when you upgrade a project, by default, it's turned off.
Yeah, and that kind of sort of nuanced way that you deal with new and old behavior is sort of something we've been dealing with in Silverlight now for a while. This idea of quirking the runtime behavior between different releases. And so you have Silverlight 4, let's say they'll fix a bug that was there in Silverlight 3, but some Silverlight 3 app could be depending on it. And Silverlight's definitely a place where you just have one release. You're not going to have a whole bunch of side-by-side versions of Silverlight installed, typically, especially on the web. And so in that environment, you really do need to be able to make a Silverlight 3 app that's just already deployed, where the user independently upgrades to Silverlight 4, have that app behave the same way that it used to. And so it actually will go and look at the app. And we're starting to look at doing that kind of thing more in the compilers. Like we were saying here, you can do it during upgrade to say that we know that this project originally came from this environment, so we should turn off this warning. Especially as we get to like compiler as a service and stuff, where it's really even more explicit that the compiler is going to be used and consumed as part of applications, that we really want a way that we could say, hey, we're going to fix this bug. It's clearly wrong, but you could have ended up depending on it and worked around it yourself, and now your workaround will break things if we fix the original issue. And we have to be pretty cognizant of that.
Yeah, so compatibility, definitely extremely important topic. And Jason Zander did make an announcement earlier this year about the next release that we will actually be maintaining project compatibility. So you know that we've added multi-targeting so that you, in previous releases where you can target specific versions of the framework, now you can actually kind of building upon that. If you have a project targeted at 4.0 in Visual Studio 2010 and you move to the next release and keep that targeting, then you will be able to use that same project without upgrading it so that you can work side by side with team members in Visual Studio 2010 and the next version. And
it's interesting, like you look at when we sort of prototype language features, so if you get the async CTP today, there's new tokens that we added. So there's an async keyword basically and an await keyword. And I believe in the CTP they're actually still real keywords. But then in the actual release that we're doing, when you think of what's the extra work you have to do between releasing a CTP, this seems like it pretty much works, and then going to the productized version. We do what we often do with these releases, where we have to go back and make the keywords we call contextual keywords. And so if you use something like async, or I'm sorry, if you use async in certain contexts, you usually will say like, public async and then the name of a method or a type for a method. You end up being in a place where it could be ambiguous. You could end up having in a place where you could have had a type name, or you end up in places within methods where you're talking about async lambdas, and some of these things can be ambiguous with other tokens you could have had already. And we have to take care of that just in case you had tokens already named await and tokens named async. And so we have to ensure that only when you're in a context where your method says async will the await keyword inside that method actually be treated as if it was the await keyword, and come up with sort of nuanced rules. Remember some of the arguments we had in the VB and C# design meetings about, well, what about in this case? Is this corner case enough? Would anybody reasonably have called this lowercase await, and so on? And we often keep ending up siding back on the side of, well, let's do the extra work in the compiler. Let's contort the language rules a little bit, but do that to ensure the backwards compatibility. You sort of have that most flexibility in V1. You have to really care about this more and more since then.
So I think one of the unique things about the Visual Studio languages group team is that as they do language design, then tooling for the language is so much on their mind. And often, even coming from a more academic background in languages work, then I was pretty shocked when I first saw C# 1.0 being developed and 2.0 during the generics work, just how much that syntactic things mattered in terms of getting good IntelliSense. Just that half of these discussion meetings would be about, as the user types this, will we be able to give good IntelliSense, good interactive hints for the program text, and that interplay, and that's gone into all sorts of other areas as well. I think with refactoring and all sorts of other things that have been done
Link
since
would be
then.
a great example
Link
where
is a
we
very
did
good
early usability studies where initially we had link statements starting with select, right? You want to say what you're selecting.
Matching
But-
SQL, right? Yeah.
Yeah, it looks just like SQL, but then we can't give you an IntelliSense because we don't know what you're selecting from. And so we saw people try to go through this syntax, but without IntelliSense, it just was not a good experience. And so that was inevitably, just as you say, the IDE experience directly influenced the language design there.
Yes, that's a very rare thing in the industry. If you look across language design efforts across the industry and academia, that's really unique, almost unique. Yeah.
Okay, so the next couple questions that we have here are different language design scenarios. So I wanted to ask Don, in creating a new language, F#, also written in F#, the experience and kind of any interesting, different scenarios that you run into there. And then also go to Lucian, looking on the other side at VB, which has been around for a long time, the different types of challenges that you face as a language matures.
Yeah, well, there's some extent that F# wasn't a new language in some ways. We did have a lot of freedom in its as we made it, but its core syntax was based on the OCaml core syntax, a variation of it with a lightweight syntax, indentation-aware syntax version of the OCaml syntax. So I don't think I ever thought of myself as creating an entirely new language. And there are some elements of the F# design which you'll see vestiges of OCaml. Some bits which, if you really pushed me, I would only be able to fully rationalize because of the relationship with OCaml. And we know that, and that was an important part of how we bootstrapped the language and the language community. That said, we did get a huge amount of flexibility. We didn't have to cope with some of the backward compatibility issues that you guys had to deal with. Probably the hardest thing in F# 2.0, which is the version we shipped in Visual Studio 2010, is that we actually had to play catch-up with. When you look at the features that are in F# 2.0, it's more fully featured than than C# vNext in some ways, and minus the link. We didn't do a fully complete job on link queries in F# 2.0, but we really had to put quite a lot of stuff into F# 2.0 in the first release, partly because C# had set a very high standard at VB as well, in terms of the functionality that people expect. And compared to the Java 1.0 days or the the Ada days, or way back in the history of languages, people do expect to have a lot of goodness in their languages right up front these days.
Great. Lucian?
You know, the striking thing about VB is that if you take a program written in QBasic in the early 80s, and if you stick the module keyword at the front of it, it'll compile pretty much clean in Visual Studio 2010. That's really extraordinary. I mean, it's weathered so many paradigm shifts from spaghetti code with gotos, then go-subs, then procedures, then object orientation, then functional and lambdas, declarative, XML. It's a language, strong type systems, dynamic. It's a language that has weathered an enormous number of paradigm shifts. We're asked, why do you still have VB? Why not just ditch VB and put all your effort into C#? And that's the exactly wrong attitude. What a gentleman here was saying was it's about not leaving people high and dry. It's about discovering how you can make a language and change its paradigm and add completely new ways of programming, like LINQ, like async, without compromising its fundamental character, without breaking compatibility, without destroying the assets that you've leveraged. How do we do this? I think it's one of the biggest challenges that we have as language designers for real languages, not just for academic toy languages. And one rule of thumb we have, right? We have to decide whether we add a new language feature in the first place. So let's figure it this way. Each new language feature we add, you guys have to learn about. Some of you think, oh, great, a new language feature. Most of you think, oh, another language feature. That'll cost me 2 weeks of productivity just to learn what it is, learn its syntax, learn what the best practices around using it, learn how other people have done it, evaluate it, whether my team should adopt it, teach the rest of my team how to use it. So, we only add a new language feature if we think it will be worth your investment in learning it. The second principle that we've got for adding new language features is, and I think LINQ and VB's XML LINQ tools are a great showcase of this, start with something that isn't a language feature. Start with an API that's in the framework. Whenever you program LINQ, you can do it using purely framework methods and lambdas. Well, in order to do that, we had to add some pretty foundational computer science concepts into the languages, like lambdas, like quoting. But once we've got these tried and tested basic foundational computer science things, from maths, from computer science, into the language, then we know that we're on firm footings. We know that there aren't any unexpected edge cases. We can add the features, and then we can start adding the rest of LINQ, or the rest of XML literals, as syntactic sugar. What I mean by syntactic sugar is, it's merely, basically the compiler looks at what you've typed, and it expands it out into an older version of the language which doesn't have that feature. What that does is it gives us really good reassurance that the feature we're adding will not have unexpected corner cases when we add new features in the future, that it will be a good solid foundation and it will work well 10, 15 years in the future. That works most of the time. There was an own goal we find, I think, in VB. Let me just tell you about this. I'll spend 1 minute. We added nullable types. And we thought, okay, nullable has a straightforward principle. Every structure type has a nullable version of it. Every operator has a nullable version of that. So think of the plus operator, which operates integer plus integer gives an integer. Therefore, nullable integer, nullable plus, nullable integer gives nullable integer. That makes sense. And the meaning of nothing, or null, is I don't know what the answer is, what the value is, like SQL. So, VB started with his hardcore foundational computer science purist approach. What happens if you use the equality testing operator on nullables? We said we started with the plus operator, we lift that. Let's start with the equality testing operator. What happens if you have nothing equals, well, if we had 5 equals 5, the answer is true. If we had 3 equals 5, the answer is false. If we had nothing equals 5, because we've lifted everything, the answer in VB is nothing. So, a user writes their code, dim x equals nothing. If x equals nothing, then print nothing. What does that do? It doesn't print anything at all, because we lifted the equality operator as well. And nothing equals 5, or nothing equals nothing, the answer is nothing. I don't know. We said, is this value that I don't know equal to that value that I don't know? Answer, I don't know. Okay, that can found for every single one of our users, and that was kind of a mistake. We should have gone for the more pragmatic C# approach there. Don't worry about the purest approach, just do what 99.9% of our user base will expect. Actually, we should have gone for if 95% of our user base will expect it. That's probably a good threshold.
Thanks, Lucian. So what I want to do at this point is invite folks to come up to the microphone. We really want to hear from you, and if there's any questions that you had, while we were going through this discussion, or while you're coding day in and day out and you wonder why these languages are this way, please do go ahead and come up so we can hear any of your questions. And then while people are doing that, then I'm going to open up the panel for any other language design tips that you've learned going through this process that you want to share with the group.
While you're thinking of your questions, I'm going to start with one. Countermeasures, right? I got this idea from watching 70s sci-fi films. The hero and the heroine are trapped, and they say, computer, open doors. And the computer says, I'm sorry, I can't do that. Dr. Evil locked all of the doors. And you say, computer, override that and unlock the doors. And the computer says, I'm sorry, Dr. Evil disallowed all overrides. And they say, computer, override Dr. Evil's override. The computer says, okay. Computer, override Dr. Evil's lock. Okay. Computer, open doors. Okay. What's happened there, and this happens in language design all of the time, is that whenever we discover we're putting a measure and a countermeasure and a countermeasure in, we can tell that we've gone in the wrong direction. I'll give you a practical example. Treat warnings as errors. Oh, this has hurt us so many times. Users, let's suppose someone says, treat warning 4020 as an error. That works great in the next release where warning number 4020 exists. Doesn't matter what 4020 is, I just invented that. What happens if they put treat warning as error for 420 in a previous version which does not have warning number 4020? Oh, the compiler should report a warning about this. Or should it report an error about this? Or what if the user treated warnings as errors and they put this in their code to make it work in the next version and the previous version? Maybe we should put a special exemption so they can override treat warnings as errors for warnings which haven't yet been done. But what if the user wants to actually put an exemption to that exemption? Okay, we've gone in the wrong direction there.
Yes, please.
So oftentimes in academic settings, the toy languages are implemented with tools like a parser generator. I'm curious if you guys use any of those tools like Yak in your development or prototyping, and how those tools either constrain or assist you in your language design tasks.
I'll answer that. So we do use a version of Yak in the F# implementation. It's called F# Yak. You can find the code for it up on Coplex if you're interested in what's called the F# Power Pack. I think we are unique in Microsoft languages in doing that. I think all the others use recursive descent parsers. I don't think VB uses
VB and C# are too expressive to be done in Yak. They need a general look-ahead parser. We've experimented with a few. We never got good enough quality error recovery from those.
Yeah, it certainly has helped to have full control over that tool. We wouldn't have been able to do it unless we've been able to modify the Yak, F# Yak, to be able to give much better error messages, to give you a lot of information about the state of the parsing engine. Though, I have to say, general wisdom at Microsoft is that you should write a handwritten recursive descent parser. That's how it's traditionally been done. But, I've been pretty happy with using F#YAC. It certainly allowed us to put language features in. Probably the greatest thing about the F# code base is it's historically has always been a completely unified code base, so that the IDE tooling is also the interactive type checking and the IntelliSense implementation, everything is based off the same code, so that as we added a feature to the language, it lit up immediately. Literally, you just added it and it would just work in at least a rudimentary form in the IntelliSense work.
Great, go ahead.
Yeah, I had another question on the business side. Thanks for answering the stuff about compatibility and life cycle. There was a circle about declaratives earlier, and I'm wondering, I mean, the most expensive thing about coding is that it's expensive to do, and anything we can automate in error checking. So what about stuff like constraints and provability? That was one thing that was hot in the academic area. I mean, and declarative kind of ties into that as a baby version. So where are you all going with that?
So there's a huge amount of work, activity at Microsoft Research on different ways to do logical analyses of programs and to help programmers find bugs and to help people in their coding process by using various forms of logical analysis and proof over code. Some of that is done over C++ code, so some of that is driven by the needs of Windows and historically Office, although mostly focus on Windows, especially Windows device drivers, for all sorts of reasons we know about in terms of improving their quality. And I honestly think the quality of Windows 7 device drivers, I mean, has improved enormously, partly because of the tools you get in the Windows device driver DDK now, which include a major logical analysis called the static driver verifier. On the managed code side, some people doing the logical analyses are a little bit disappointed to suddenly find that whole classes of errors don't really occur so much, like array bounds errors and the like. You don't get memory corruptions because of those. So there are fewer bugs for them to chase, fewer what we think of as implicit bugs in code. Like they can still try and chase null pointer dereferences and so on, which are considered always to be bugs whenever you have them. Now, then there's this other class of work which is to do with writing your specifications, very tight specifications or partial specifications of the correctness of your program, maybe putting an attribute on your code saying this bit of code, this function always returns this mathematical expression or in some way. You can see that in the code contract work. Yep. People have been working a lot on finding different manifestations of the code contract idea. Whether you do a whole new language like Spec Sharp or a whole version of C Sharp. There was a lot of academic languages which support some kind of code contract checking, but we actually have code contract checking for C Sharp in VS 2010. And
yeah, that was a collaboration with the research group and the CLR group.
Yeah. And you can actually look through the annotations in MS Core Lib. You can see all the different kind of code contract annotations that are added all the way through that work as well.
Okay, and then adding on to that, sort of a lightweight version of that, and a classic version we've had a long time is better error messages like lint and stuff like that. And my ears perked up when you said you have an internal goal to get out quality code, and you demanded a better YAC error message. So what are you doing in that area? I mean, on each release, are you giving us better quality error message? So you discussed some of the problems that, if you blow up people's code, they might get angry. But I mean, do you add the options? Do you consider that? Because it's a tremendous money saving if you can, the guts of the language, and you can put in better error messages rather than buying a third party or they don't even exist.
This is something that we've always cared about. Like one of the things we were proud of most, I know specifically from the C# side, I'm sure from the VB side also, was in 1.0 that we actually had very high quality error messages. We go out of our way to sort of deduce further, like we know it's an error, but we can give one of 3 errors based on what we think you're trying to do. And something you'll notice, like if you forget a curly brace, for a lot of compilers, this could be a tragic explosion of errors afterwards. And we have a lot of heuristics that we get from having this more custom parser to figure out, hey, after a class, if I'm seeing the word public class again, well, that's probably the start of a new class. And I can interpret everything after that, and I can assume the closing brace was there and give proper errors for the rest of the file. And so we're able to build in a lot of those heuristics. We take doing that kind of stuff pretty seriously when we add new language features, especially new ones that really affect syntax a lot, like lambdas and things where you're going to have a huge explosion of possible things. Hey, if I get this wrong, do I still get the right thing in the rest of the file? And it's important to us.
One thing we're thinking about is having Visual Studio be able to look at the code that you've written and come up with suggestions. We imagine probably an animated paperclip that would sit there. So I'm kidding, but really, we're very conscious that we need to improve this. We look at things like the light bulbs that appear just contextually when you write a Word document, or saying change the grammar. We are thinking hard about ways that we can communicate our ideas about best practice to the users in some contextual way. Something that isn't as harsh as an error message or a warning message, but we really have good value, good advice, good code snippets, good references. I would love to have discussions with you guys afterwards about your ideas of how we can do this. As we're moving to compiler as a service, that is something very high in our mind.
Thank you.
Okay, so I wanted to point you at a few resources and then also talk about other opportunities during the week where we can get together to continue these conversations, hear more from you, and additional sessions. So here are the sites for each of our languages here, just kind of a single reference point that you can take down, and each of these developer centers have RSS feeds of our blogs, links to downloads, and more. And you can get these slides also from the TechEd website, so you can get those there. Related sessions and booth. So in the Technical Learning Center, we do have a booth called Visual Studio Languages, and we'll be staffing that throughout the week. So please do come on down there at any time to come chat with us. Tonight there's actually the TLC and Expo reception, so I think from around 6:30 or so to 9, we'll be there with a bunch of folks from the team. And then tomorrow we actually have another session. This one's going to be very interactive. We'll be there representing languages. This will also be the rest of our team with IDE and extensibility, project, and build system. This one's going to be very much Q&A driven. So if you do have additional questions that you want to discuss with the team, that's a great venue to bring them. Then looking at the sessions that we have planned, where we'll be demoing lots of the features that we talked about today. Lucian has a session on using VB to build phone apps. Alex then has a session on C# and VB. Async, a really large investment for the next release. He'll be doing the latest demos there. Then Don has a session on F#, so he'll be showing the type providers work that we talked about today. And then finally, Mark Michaelis, one of our MVPs, has a session on the last day of the conference. It's called Upgrading Your C# Programming Skills. And this is, we talked about that problem that we add all these features, but sometimes people say, well, I have the latest release, but I'm still trying to learn all the features that you added already. This is a great session where you kind of went through all of the features that shipped in prior versions of C# and really looking at the ones that you end up using all the time, or that later features depended upon, and kind of building out that repertoire. So please do complete an evaluation for this session. We're really interested to hear your feedback, and we love having the opportunity to come here and chat with you all about the design process. And with that, I'd like to thank our panel. It was really great having everybody here, and thank you, everybody.